Okay, a little bit more detail on reflection in this slide, and remembering the rule, the law of reflection, that an incident ray that's being shone onto a mirror will be reflected at the same angle. We say the angle of incidence, angle I, is equal to the angle of reflection, angle R. This explains why on a smooth surface, particularly a shiny surface like a mirror, you can see an image, and we say that this is due to specular reflection. In other words, the light is not being scattered like it would be in a rough surface. So a mirror is an example of specular reflection, and an image, which you can see here, forms in the mirror, and we can say that this image is the same size, is upright, laterally inverted, and importantly is virtual. In other words, to explain where the image is, we have to imagine rays of light traveling to it, but no light is really going behind the image. So going back to this mirror diagram here, when you look in a mirror, the image appears to be the same distance behind the mirror as the object is in front of it. The opposite of specular reflection, like you would get in a mirror, is diffuse reflection, and how we see stuff is an example of this. We see things because of light reflecting from them. So when you look at somebody and see their blazer, the light is hitting the blazer and being scattered, which is why the surface looks dull and not shiny. Refraction, it's very important that you can explain why refraction happens, which we do by talking about the speed of this wave changing as it enters the glass block, a denser material. So light is refracted, for example, because as it enters the glass block, it slows down, and because it's hit the block at an angle, it slows down on one side more than the other, which causes it to change direction. If this was a car driving into some concrete, the car would skid if it hit the concrete at an angle, but continue in a straight line once it's inside the material, and then again speed up as it leaves. So we can remember the rule for refraction: as a wave enters a denser material at an angle to the normal, it bends in. When it goes in, it bends in towards the normal. R is smaller than I. And as the wave leaves the block, it bends out as it speeds up when it leaves the glass block and goes back into the air. So we explain refraction in terms of the change of speed, and we say that refraction will only happen where the wave is hitting a boundary at an angle that isn't right angles. A prism can be used to separate white light into its colours using refraction, because the different wavelengths of light are bent through different angles, and so you always get the same order, with the shortest wavelength, higher frequency violet part of the spectrum bending the most.